Hello, welcome. This is CH Arvind Kumar, Assistant Professor, Department of Computer Science and Engineering, Vagdevi College of Engineering. I am going to explain Network Security and Cryptography Lab. Week 2 program is Write a program to implement Hill Cipher. Hill Cipher was developed by the mathematician Lester Hill in 1929. In Hill Cipher, M successive plaintext letters are substituted with M ciphertext letters. The substitution is determined by linear equations in which each character is assigned with a numeric value, like A is assigned with 0, B is assigned with 1, C is assigned with 2, and so on, Z is assigned with 25. First, sender and receiver selects a key matrix with size n by n, and the key matrix is invertible. Then sender converts his plaintext into plaintext matrix. For that, sender breaks the plaintext into length of n blocks to form a n into 1 vectors of plaintext matrix P. If necessary, add extra characters to plaintext. To perform encryption, key matrix is multiplied with plaintext matrix and the result is mod with 26. To perform decryption, first we are going to find out inverse of the key matrix, and that inverse of key matrix is multiplied with ciphertext and the result is mod with 26. We'll discuss Hill Cipher with 3 by 3 matrix example. Assume our plaintext is high, HAI. First convert this HAI into numbers, then it will be converted to plaintext matrix. This is our plaintext matrix. H represents 7, A represents 0, I represents 8. Then select key matrix. Our key matrix size is 3 by 3 and the elements in the key matrix is 2, 8, 15, 7, 4, 17, 8, 13, 6. First check whether the key matrix is invertible or not. For that, find out determinant of the key matrix, and the determinant should not be equals to 0. Next, multiply the key matrix with its inverse. The result must be an identity matrix. Start with our first step, finding determinant and its inverse. To finding determinant of 3 by 3 matrix, assume this is our 3 by 3 matrix. The determinant is found out based on this equation. A is multiplied with EI minus FH. Next, minus B multiplied with DI minus FG. Next, plus C multiplied with DH minus EG. By using this equation, we are going to find our determinant. Our determinant is 1243. Next, we are going to find inverse of this determinant. For finding inverse of determinant, use this equation. D multiplied with inverse of D and it is equals to 1 mod 26. We know the value of D, we don't know the value of D inverse. We are going to find this D inverse only. So for that, we can rewrite this equation. This is the value of D, 1243 into D inverse and mod 26 equals to 1. When this will become equals to 1, when we multiply 1243 into 5, we will get the result as 1. That is 6215 mod with 26. The result is 1. So we can write D inverse equals to 5. The second step, we are going to find adjoint matrix of our key matrix. For that, we are finding cofactors. To find cofactors of our key matrix, use these equations. So to find C11, the first element in the matrix, it is representing positive position. So it is multiplied with positive 1 and the element row and column is deleted. So we are finding this first element C11. This row and this column is deleted and remaining diagonal elements are multiplied. 4 multiplied with 6 minus 17 multiplied with 13. The result is minus 197. In the same way, find next element C12. C12 is representing negative position. So it is multiplied with minus 1 and delete the row and column. Multiply diagonal elements in the matrix. 7 multiplied with 6 and 17 multiplied with 18. So 7 into 6 minus 17 into 8. The result is 94. In the same way, find out remaining elements in the matrix. Finally, we got the result. That is minus 197, 147, 76, 94, minus 108, 71, 59, 38, minus 48. In this matrix, we have negative elements. We have to convert these negative elements to positive. For that, we are using mod 26. If we perform mod 26 with all these elements, the result is our adjacent matrix. That is 11, 17, 24, 16, 22, 19, 7, 12, 4. This is our adjacent mat. By using this adjacent matrix and our determinant, we are going to find modular arithmetic inverse of our key matrix. So we can rewrite the formula, that is K inverse equals to D inverse into adjacent of K. Our D inverse is 5 and adjacent of K is 11, 17, 24, 16, 22, 19, 7, 12 and 4. If we multiply this, we will get the result as 55, 85, 120, 80, 120, 95, 35, 60, 20. Some elements in the matrix is greater than 26. Now we are going to convert less than 26. For that we are using mod 26. And finally our key inverse is 3, 7, 16, 2, 6, 17, 9, 8, 20. Now we are going to check the key matrix and its inverse is generating identity matrix or not. For that we are multiplying key matrix and inverse of key matrix and we are checking it is generating identity matrix or not. Yes, it is generated identity matrix. Now we can use this key matrix for our encryption and decryption. Our plain text is hi, HAI. Convert this HAI into numbers as a plain text matrix. 708 is our plain text matrix. Our key matrix is 2, 8, 15, 7, 4, 17, 8, 13, 6. Inverse of this key matrix is 3, 7, 16, 2, 6, 17, 9, 8, 20. Determinant of our key matrix is 1243. First, perform encryption. To perform encryption, key matrix is multiplied with plain text matrix and the result is mod with 26. Our key matrix is 2, 8, 15, 7, 4, 17, 8, 13, 6. It is multiplied with our plain text matrix, that is 708. And the result is mod with 26. The result matrix is 134, 185, 104. This matrix is mod with 26. And our final result is 430. Convert these 430s into characters, that is our ciphertext. 4 represents E, 3 represents D, 0 represents A. Now send this ciphertext to receiver. Receiver got the ciphertext. Now receiver is going to convert the ciphertext into plain text. For that, inverse of key matrix is multiplied with ciphertext and the result is mod with 26. Inverse of key matrix is 3, 7, 16, 2, 6, 17, 9, 8, 20. It is multiplied with ciphertext matrix, that is 4, 3, 0 and the result is mod with 26. We got the result, that is 33, 26, 60. This matrix is mod with 26 and final result is 708. Convert this 708 into characters. 7 represents H, 0 represents A, 8 represents I. In this way, encryption and decryption is performed by using Hill cipher. This is sender program. Sender is going to perform encryption. To perform encryption, we are going to read plain text as well as key matrix. After reading the key matrix, we are going to find out determinant of the key matrix, encryption by using key matrix, and this encrypted text is forwarded to receiver. This is receiver program. Receiver is going to perform decryption. To perform decryption, first the receiver is going to find out inverse of key matrix. First, receiver reads the key matrix. From that key matrix, determinant is calculated. Inverse of key matrix is calculated. With this inverse key matrix, the ciphertext is multiplied so that we will get plain text. Now we will see how to execute the program. We have two programs. One program is for sender and another program is for receiver. These two programs is executed in two different computers. Sender encrypt the text and encrypted text is forwarded to receiver. Receiver is going to decrypt the text by using the Hill cipher technique. As you are staying in home, you are unable to perform execution in two different computers. That's why I am executing the program in single system with two different terminals. For that, first execute receiver program, open terminal and compile the program. To compile the program, command is cc space program name dot c space -o. -o will create an output file. That output file is copied into new file hr. To run the receiver program, call the output file, that is hr.exe. Yes, receiver is ready to start the communication. Now open another terminal for sender. To compile sender program, cc space program name dot c minus o and new file name. To execute the program, output file dot exe space IP address of receiver, that is 127.0.0.1. This 127.0.1 is loopback address. Here, if you are executing this program in two different computers, you have to specify the IP address of receiver system and specify port number of receiver system, that is 13154. This is receiver system port number. This message shows the connection is established between sender and receiver. Now sender enter plain text hi. We are using 3 by 3 matrix, that's why we are using 3 here. Now enter your key matrix, that is 2, 8, 15, 7, 4, 17, 8, 13, 6. This is your key matrix. This is determinant of key matrix. This one is your plain text and the generated ciphertext is EDA. This ciphertext EDA is sent to receiver. Now check at receiver system. Yes, receiver received ciphertext EDA. So we are using 3 by 3 matrix. Enter your key matrix, that is 2, 8, 15, 7, 4, 17, 8, 13, 6. After entering the key matrix, this is your key matrix. It will calculate determinant of the key matrix and it will calculate inverse of the key matrix. With this inverse key matrix, ciphertext is multiplied and the result is mod with 26, so that it will generate the plain text HAI. Hi. In this way, the program is executed. Thank you.